Okay guys, we have two SAT math questions here. The first, number 13, says in the system of equations above, what is the value of x plus y? So since we have three variables here, x, y, and z, but we only want to end up with x and y, we want to isolate z in one of the equations so we can plug it into the other equation and get rid of it. To do that, we're going to start with our second equation. Because z is by itself, it'll be easier to isolate in fewer steps. So we have x plus y plus z equals 400. If we subtract out the x from both sides and y from both sides, we're left with z equals 400 minus x minus y. Now we can take that and plug it into our second equation, our first equation, where we have x plus y plus 3. Again, we're going to plug in this z right here. We have 3 times 400 minus x minus y equals 600. And now we're going to simplify this by distributing out our 3. So we have x plus y plus 1200 minus 3 times negative x, negative 3x. 3 times negative y is negative 3y equals 600. We're going to want to collect our like terms. So here we have x and negative 3x gives us with negative 2x. Y, negative 3y gives us negative 2y plus 1200 equals 600. Now we're going to want to move our 1200 to the other side to isolate our x and y. Minus 1200 minus 1200, that gives us negative 2x minus 2y equals negative 600. Now we can see that we have a negative 2 common to both our x and y terms, so we can factor that out. Negative 2 x plus y, because remember we factored out that negative, equals negative 600. And if we divide both sides by negative 2, we are left with x plus y equals 300. And that is our answer for problem number 13. Moving on to question 14, there are 25 trays on a table in the cafeteria. Each tray contains a cup only, a plate only, or both a cup and a plate. If 15 of the trays contain cups and 21 of the trays contain plates, how many contain both a cup and a plate? So looking at this question, we know that we have 25 trays. We have 15 trays containing cups, so we have 15 cups. And we have 21 trays containing plates, so we have 21 plates. Now if we take our 15 cups and distribute them out onto our trays, we will have 25 trays minus 15 trays with cups, which will leave us with 10 trays without cups. We know that these 10 trays without cups contain only plates. So, out of the 21 plates, we know that 10 of those will go towards our 10 trays without cups, which will leave us with 11 plates that went to trays with cups. This means that our answer is 11 trays that contain both plates and cups.